Yeah. So good evening, everyone. Good evening. Good evening, everyone. Please let me know audio video okay or not. Is audio video okay? Check once. If audio video okay, we can go ahead. Right? Can we go ahead? Most probably, I think audio video okay. Check audio video okay. Please comment in the comment section. Check once. Yeah. So that's the reason I came. So because making content taken some time, some delay happened. Yeah, can we go ahead then? Yeah, let's start this. Let's start the class. I think we can start. Just give me 1 minute. I'm sharing the screen. Yeah, let's give the 1 or 2 minutes. I'm sharing the screen. Yeah, let's go to, yeah, this is the topic. So we can go ahead. We can go ahead now. Yeah, let me start one by one. So today's date is, I think, 27. Today's date is 27/1/26. 27/1/26. Today's date. So I'm starting TOC. Whatever, right? So I may not say anything new. Whatever you know, I will say one time. If any important point is, if anything you feel important, so please take it. Right? If you know all the points are whatever you know, then it's absolutely fine. There is no objection at all. At any point of time, any doubt, in the comment section, you can comment. In the comment section, you can comment. So I'm starting TOC revision course 27/1/26 date. So I'm starting now. Formal language. I think everyone know formal language, right? So the first chapter name is formal language. In that, some basics. What is the alphabet? No one will ask in the examination. Just I think just I'm covering overall view one time. Formal language, right? So first chapter name is something like formal language, where all the basics will come, right? So see the first one, alphabet, right? A finite set of symbols, right? A finite set of symbols is nothing but an alphabet. Next one, string definition, right? Collection of symbols. Language, collection of strings, right? Next one is Chomsky hierarchy. Means according to Chomsky, there are 4 types of formal languages: type 0, type 1, type 2, type 3. So you know this very well. These are very small things. No one will ask you. Just all right, to cover the overall thing, I kept here. Formal language internally includes, right, alphabet, string, language, right? According to Chomsky, how many formal languages are there? There are 4 there, right? Type 3 to type 0, right? So next one, if you see the finite automata, regular language, type 3. Grammar is type 3 grammar. Push down automata, if you see, context free language, type 2. Linear bounded automata, context sensitive language, type 1. Turing machine, recursive enumerable language, type 0. Right? If you see the expressive power means the number of languages accepted by every automata. The number of languages accepted by every automata, right? I think if you observe clearly, recursive enumerable language, Turing machine. So if you observe expressive power, in terms of expressive power, if you see finite automata is less expressive power. Finite automata is right less expressive power than PDA. PDA is less expressive power than context sensitive, LBA, right? LBA having less expressive power than Turing machine. So among all of them, finite automata is a smaller expressive power, means it can accept less languages, right? So Turing machine is the higher one. Everyone know this. In terms of expressive power, automata's relation is this. In terms of expressive power, so Turing machine way more expressive power is it will accept type 0 also, type 1 also, type 2 also, type 3 also. 4 things it is accepting. But if you see the finite automata, it is accepting only type 3. It is accepting type 3 also, PDA accepting type 3 and type 2 also. This is accepting type 3, type 2, right? Type 1 also. This is accepting type 0 also. That is that right? More languages it is accepting, more expressive power. So expressive power also everyone fine. Empty string. Epsilon is a special person. Remember, it is a one string whose length is 0. It's a very, very important. Total TOC running on this person only. Total TOC running on this person. Total TOC. It's running on this person. If you know this person, you know TOC. Through my experience, I'm saying, if you know this person, you know TOC. So try to understand this, right? Empty string, which is also called epsilon, right? Why it is called empty string? It is not empty language, empty string. Why it is called empty string? Because length is 0. That symbol length is 0. How it is possible? There is a one person whose weight is 0. How it is possible? It's a surprise. In the total TOC, it is a surprise. So visually, I cannot show, right? There is a something whose weight is 0. How it is possible? That is the reason it is a surprise. So if you can remember that epsilon, I think most of the things are okay. Remember, epsilon is a empty string, but pi is a empty language. Pi is a empty language. What is the meaning of empty language? Simply brackets inside nothing. The number of string in the language is nothing. That is called empty language. So remember, epsilon is different, pi is different. If you can see the difference between both of them, can we get this PDF? Of course, you will get it. Of course, you will get it. So remember, these two are not same. Epsilon and pi, both are not same. So epsilon means like this, right? Pi means like this. There is a difference between both of them. Right? There is a difference between both of them. Try to understand this. So this also completed. Empty language. This also come. Next one. Length of the string. So simply length. So I think W is ABC. Length is 3. That is also okay. So nothing. Just I want to revise one time. More than that, nothing is there. Right? Now come to here. Finite automatas. If you see, right? Finite automatas are two types. Finite automata with output. Finite automata without output. Okay, so if you see without output, if you see without output, finite automata without output, if you see, right, let's see this one, right? DFA is there without output, NFA is there, epsilon NFA is there. Finite automata with output, if you see more machine, milli machine, right? That is okay, everyone know this. Let's come to finite automata without output. If you see the without output, finite automata without output, if you observe, right, I think all parameters are there, right? What is the finite automata, right? Finite set of states are there, right? Input alphabet is there, sigma, transition function, delta there, starting state is there, Q0, set of final state, which is FE subset are equal to Q, right? You know all these things, right? Some description about initial state, final state. Remember final state. So final state FE subset are equal to Q. Final states are normally represented by double circle. You know this very well. You know this very well. Right? Dead state. Right? Dead state. Right? Dead state in the sense, dead state is that state where if you go to dead state, you cannot come back. It is not a final state, it is a non-final state. Dead state is a non-final state. And if you go there, you cannot come back. It is something like in the human life, right? The person who dead, which is nothing but a dead state. Behavior-wise, both are similar. Dead state and the person who dead. Dead state, another name is a trap state. Remember, dead state is a non-final state. But what is the difference between normal, non-final and dead state? Right? So let us assume that, right? Non-final in the sense, patient. Non-final in the sense, patient. But when you say dead state, the patient who is already dead. But when you say patient, right, maybe is if at all, if you give proper medicine, he will be all right. But dead state means he's already dead. So similar behavior in the automata also. There is some state, if you go there, you are rejected, okay, but permanently rejected. If you go to some state, permanently rejected, I think you can see this kind of state. See the state number C. If you come from starting state to C, because of C is a no double circle, it is rejected only, but forever rejected. Rejected is called as non-final. Forever rejected is called dead state, which is also non-final. Right? I think everyone know. Just I think only for namesake. Right? Only for namesake I'm explaining. Next one. If you see the finite automata's types with right without output, DFA there, NFA there, epsilon NFA there. DFA, NFA, epsilon NFA. You see the transition function, you will get the clarity. DFA transition function, if you see Q cross sigma 2Q. Q cross sigma 2Q, that is a DFA transition function. If you see the NFA transition function, 2 power Q, that is the difference. But if you see the epsilon NFA, here epsilon also allowed. Whenever epsilon free NFA, it is not there. Simply NFA, it is not there. But this is there. But right, when you say epsilon NFA, this also there. Right? Fine. Perfect. Right? You know DFA, you know epsilon NFA, NFA. You know this very well. Right? And one more thing. So you know NFA, DFA differences. Everyone know. Can empty language have epsilon? Empty language don't have anything. See, empty language means this. This is the empty language. Empty language means, right, language having nothing. That is called empty language. Right? Fine. Right? Next one. I think if you observe, right, I think something about non-determinism, which everyone knows. Non-determinism, everyone knows. Right? You can read once. Non-determinism. Right? What is the meaning? Some symbols on some state, by giving some symbols, you are going multiple transitions. Multiple transition. That is called non-determinism. Right? So when you say NFA, non-determinism. When you say DFA, determinism. Right? DFA having determinism, non-determinism. NFA means non-determinism, means there is some ambiguity. Right? I think you can see, right? I think let's see the example. All strings, I think, wait. If any examples are there, I will give. Yeah, perfect. Now I think you can see here. Language. Let's see everyone this problem. All strings over AB that end with AB. Ending with AB. Right? Try to understand this one. So on Q0, A, I will go to Q1. On Q1, B, I will go to Q2. Then final state. So then you may say that what about see, if you see the right, A here also, A here also, that is called non-determinism. That is called two behaviors ending with AB there, but remaining thing, if you observe, there may be some issues. So what I want is non-determinism, there is some ambiguity. See, multiple transitions somewhere, and some state you didn't mention something. You know very well right? You know very well about NFA. But if you observe clearly, in our classes, right? NFA we used to cover 10 problems. DFA we used to cover 30 problems. Right? This only for namesake, definition purpose I given. Right? Definition purpose I given. Right. See correctly. If for some input symbol a state has no transition or multiple transition, then that automation is known as a NFA. No transition also and a multiple transition also, that is called NFA. Everyone know this. I think if you observe clearly, above diagram, same story, right? On some state, no transition for some symbol or multiple transition. See, on Q0, A, two possibilities. Next one, on Q2, you are not saying what about A, what about B. So that is called NFA. On some state, for some symbol, multiple transition or no transition. But in the case of the DFA, right, for every state, for every symbol, exactly one transition. No ambiguity. For every state, for every symbol, only one transition. Right? No epsilon transitions are there. Complete definition means nothing will be left out. Right, next one, accept a string accepted if and only if acceptance criteria. A string is accepted if and only if the DFA ends with, right? If the DFA ends with in a particular state for a particular, right, for a particular state in final state. After processing a string, finally you stopped at the final state. String is accepted. Right, next one, equivalent power to NFA. NFA, DFA both are having same power. Right, now see one example. Minimal DFA for strings ending with AB. Right, you can see ending with AB. AB, you will go to final. Suppose after AB again some A came. A came. So I will be waiting here. B, I will go to final state. Suppose after AB, B came. I think ending problem came. I will go here. Afterwards, whenever AB will come, I will come back. So on this diagram, if you observe, for every state, for every symbol, exactly one transition, you can try this. Right? On every state, for every symbol, exactly one transition, you can verify. So that is the reason it is called DFAC. Everywhere one. Everywhere one is there. Right? Only for namesake, definitions. Who will ask in the examination? Definitions. No one will ask. Right? Just I'm giving definition so that everyone will be comfortable. Note, if for every state and for every input symbol, there is exactly one transition, then automation is known as a DFA. Okay, fine. Right? So, and DFA, so empty string purpose, DFAC. A DFA accepting empty string. Right? A DFA accepting empty string, nothing there. Starting state, final state, both are same. That is empty string. This is a DFA for that. All strings over A comma B, including epsilon. So this is, I think, right, this indication that epsilon accepted, this indication that everything accepted, right, it is accepting everything. Next one, right, DFA, minimal DFA accepting all except epsilon, starting state, final state, both cannot be same, right? You have to divide both of them. Yes, AB, I will go to Q1, which is already final state. On the Q1, anything it will accept. So except, right, excluding epsilon, everything is accepted. Next one, regular expression, right? Regular expression. It is one way to represent the regular language. To represent the regular language, one way is a finite automata, one more way is regular expression. Someone is saying, sir, stress हो रहा है, exam से दूर लग रहा है. Okay. Okay, that's a part and parcel of the game, right? Whenever you are playing game, right, some stress will come. That is a part and parcel of the game. Every game having some rules. When you are playing some game, something will happen everywhere. Everywhere, whenever competition is going on, it will happen. If you can accept that pain, if you can accept that stress, you are the winner. If you don't accept, if you take in the negative way, then you are loser. You decide yourself, you want to be winner or loser. If you are a winner, you have to handle all these things. The winner qualities are these only. Stress is coming, handle properly. Nice way handle, with smile handle. These are the qualities. If anyone want to be a leader, if anyone want to be a winner, you should have some good qualities. This is the one of the good quality. Stress coming, please. Then you will be the winner. Right? Thank you so much for asking. Sumit, thank you so much. I'm sure you can do it. I'm sure you can do it. These are part and parcel of the game. Every game, every good game contains stress. So you have to handle it. Some depression will come. You have to handle it. It's a part and parcel of the nice game. Right? Fine. Okay. Regular expression. Right? Describe this one way of representing the regular language. So union, people used to use it. Right? So this is the union, right? Normally ARB, it will be represented A plus B. Right? The meaning of this one is ARB, concatenation, A dot B. Right? So normally people will write like this. Okay, next one. Next one is clean closure, star operator. So what is the meaning of star? Matching 0 or more repetitions, including epsilon. Right? A star means include, right? Including epsilon, 1A, 2A, 3A, everyone know, one time revising, one time revision is going on. Next one, positive closure, excluding epsilon, right? 1A, 2A, 3A. Epsilon is not there. So can you see this table one time? Union, A plus B, ARB, right? So AR like this, concatenation, A dot B. That means A then B, means AB. Clean closure, A star, means 0 or more times of A. So epsilon, 1A, 2A, whatever is above. So just one more time in the form of a table. Right? Right, perfect. Next one, regular expression, A plus B whole star, A star, B star, A star plus B whole star, A plus B star whole star, A star, B star whole star, A star dot B star whole star. There are many ways are there. Many ways. Right? If you know, one more thing I want to say to you in the TOC, if you know epsilon properly, right? If you know epsilon properly, if you know star operator properly, you got the TOC subject. TOC subject you got very easily. If you know epsilon symbol properly, if you know star operator properly, you no need to do anything. In my opinion, in all the subject in computer science, easiest subject is this only. In all subjects in computer science, easiest one is this one. Very easy subject is this one. In computer science, in all the subjects, easiest one is this. Try to handle this properly. These are very easy subject. Right? Yeah, I think A plus B whole star can be written many ways. Few ways I written here. Right? Next one, A plus B, B plus A, both same. At the end of the day, ARB. AB, BA not same. Right? Be careful. AB, BA not same. Pi star. By seeing star, you have to keep epsilon. Maybe some more will come, but by seeing star, you have to keep epsilon. By seeing star, you have to keep epsilon. By seeing plus, you have to remove epsilon. But here epsilon plus contain epsilon. Right? Next one. R plus pi. Pi means nothing, means R. Right? Next one, R plus sigma. Sigma star means everything. Everything union anything. So everything. So these are, I think, normal things. Small thing. These are very small thing. You can just listen one time. Next one. Right? R concatenation epsilon. R concatenation epsilon means nothing. Right? So R concatenation nothing is going to be R only. This is the specialty of the epsilon. So can you please remember this? R dot pi is pi, R dot epsilon is R. Can you handle this? R dot pi or pi dot R is pi. These two things, if you can handle, so you got TOC subject. Right? If you know epsilon is the one who will play the game in the total TOC subject. Epsilon will play the game. Let's go to minimal DFA. Right? A minimal DFA is the smallest possible DFA that recognizes a given language. Right? And one more, minimal DFA is unique for the language. Remember, in the total automata, see this one, total automata, minimal Turing machine. Minimal Turing machine is unique. No. Minimal, this one, minimal Turing machine is unique. No. Minimal PDA is unique. No. but minimal DFA is unique. Be careful. Minimal DFA is unique. Be careful. So minimal DFA is unique for the given language, right? So what is the meaning of minimal? Redundancy is not there, unique structure, right? So how to construct the minimal DFA? How to construct minimal DFA? There is a one algorithm, you know very well, right? First of all, remove the unreachable states. Then afterwards, apply the table filling method. Or there are so many methods are there. Whatever method you learn, please follow it, right? First of all, unreachable states eliminate first. From starting state which are not reachable, delete it first. Then afterwards apply minimization algorithm, right? You can go for partition algorithm, you can go for table filling method, you can go for Mahil-Nerode theorem, right? You can go for any method you can go and indirect directly. Same behavior, make it single. Different behavior, make it different. That's what every algorithm is saying. Indistinguishable, you cannot separate them in same states. Distinguishable, you can separate it. Distinguishable means you can separate. Different states, separate. Not different, indistinguishable, make it single. So indirectly, directly, every method will say same, right? Pumping lemma. Someone is saying pumping lemma. Let me say one small thing to you. Let me say one small thing to you. Pumping lemma for regular languages. Pumping lemma for regular languages, right? So let me check. Just 1 minute. Give me 1 minute. Bro, just 1 minute, bro. Yeah, perfect. Pumping lemma, right? Pumping lemma. If see this one, if any language is regular, it should satisfy pumping lemma. Remember, if any language is regular, it should satisfy pumping lemma. Pumping lemma purpose is proving non-regularity. Pumping lemma purpose is proving non-regularity. I have a non-regular language, I want to prove it. Then you can go for pumping lemma, then you will get the finally contradiction, then you will say finally it is non-regular. Remember, if any language is regular, it should satisfy pumping lemma. What is that pumping lemma saying? Pumping lemma means loop required. Pumping name itself saying loop required. Right? If something is some language is regular, there is a DFA. In the DFA, let us assume that 5 states are there. In the DFA, let us assume that 5 states are there. Right? Now let us assume that that particular DFA accepting infinite language. Let's take a string of 5 length or more than 5 length. Let us assume that 5 states automata is there. Given language is regular. So finite automata will come. If at all finite automata is there, which is accepting infinite language, let us assume that automata contain 3 states. Right? You are able to give to that particular automata 3 length or more than 3 length also. So 3 states automata, how it is accepting 3 or more than 3? Oh, somewhere loop is there. So whenever you got to know loop is there, whenever you identify loop, that loop, if I repeat 1 time or 2 time or 3 time, it should work. But right, whenever it is a non-regular language, it don't work. So you got to know that there is a contradiction is happened. So the language, whatever is given, assume regular, then automatically finite automata will come. Then automatically you will find out one loop exists. When you say loop is exist, I can repeat the loop any number of time. When you repeat the loop any number of time, so for after repeating the loop 1 or 2 times, somewhere you got to know some failure is there. So you will say whatever I assumed is wrong. Finally, given language is non-regular. The purpose of pumping lemma is proving non-regular language as non-regular. It will give proof. Right? Just remember what is pumping lemma. If a given language is regular, it should satisfy pumping lemma. That's it. right? Pumping constant, they may ask one question, pumping constant, please concentrate on that. Pumping constant, in the previous year few questions are there, please concentrate on that, right? So remember, it is not a sufficient condition, but it is a necessary condition. Therefore, satisfying pumping lemma does not guarantee that language is regular, right? Reverse is not true. If language is regular, it should satisfy pumping lemma. If something is satisfying pumping lemma, I cannot give guarantee regular, right? Be careful. So therefore, satisfying pumping lemma does not guarantee that given language is regular. But anyhow, in the examination, GATE examination, we don't use pumping lemma anything, right? Just pumping lemma constant. Please be careful. Yeah, DFA construction problem. So can you see this one? String length divisible. String length is divisible by 3 states. String length is divisible by 3 states, right? I think like this. Divisible by 3 states. Someone is saying, let me check one small line. I'm saying that. If given language is regular, then it should satisfy pumping lemma. If given language is regular, then it should satisfy pumping lemma. Try to understand. That is the only thing what we can say. Given language is regular. Then it should satisfy pumping lemma. Right? Okay, fine. That's okay. Now come here. Other than that line, there is no use. See, I'm repeating once again. What is the purpose of pumping lemma? First statement. Proving given non-regular languages non-regular. So how you are proving? Prove by contradiction. It uses the pigeonhole principle. Someone is saying that any shortcut or tricks to solve the questions in second. Yeah, so yeah, we'll see that. Next one is going to be, if the given language is regular, then it should satisfy pumping lemma. If given language is regular, then it should satisfy pumping lemma. That is the one thing what we can say. Right? Now come here. Come here, everyone come here. Other than that, there is no requirement of anything, no requirement of debate also. Just pumping lemma constant. Just concentrate on that. It is more than enough. Right? Now come here. Minimal DFA accepting, right, every string length divisible by 3. So 3 states. Right? Next one. All strings of length divisible by, right, see this one. One more. Divisible by X or Y. Right? Divisible by X or Y. Divisible by X, everyone know X states. Divisible by Y, everyone know Y states. Something like this. But divisible by X or Y. Right? Can you see some examples on this? The minimal DFA that accept all strings whose length is divisible by 5 or 10. Divisible by 5 or 10. You know, divisible by 5 is 5 states. Divisible by 10 is 10 states. But whenever combinedly, so something like this. Whenever this language is given combinedly, there may be so many formulas are there. The minimal DFA that accept all strings whose length is divisible by 5 or 10. There are so many formulas are there. One more better idea is 5, 10. If you see the valid string, 5 length, 10 length, 15 length, I think 20 length, 25 length, 30. I think if you observe clearly, 5 difference. Whenever common difference is same, it is an AP series. Whenever difference is same, it is an AP series. When you say it is a AP series, right? So you know very well how to check the given language is regular language. If AP series is coming, means loop is possible. That's the meaning. See, with the 5 difference, there is a loop is there. That's the meaning of that line. That 5 is that only. Just to find out all the string. See, common difference is same or not. If common difference is same, I can keep that in the loop. So finite automata is possible. With how many states? So 5 states. Because 5 is the difference. Right? Just find out the sequence, what is going on. Common difference is there. Yes, common difference is there. So you can find out like that. One more way is some formulas. LCM, right? LCM, GCD, like that you can find out. right? LCM, GCD, right? Like that you can find out. I think it is the H, right? I think GCD may be greatest common divisor, the number which will divide both, greatest common divisor, so something like that. But best thing is do like this. Common difference is 5. There is a loop of 5. That is the reason, right? If AP series is forming, if anything is forming AP series, then it is going to be regular. Reason is this. Now, if you want, you can see this problem also. Can you see this one? Can you see this one? Divisible by x and y both. Divisible by 5 and divisible by 10. Can you observe this? Can you see the series here? Can you see the series here? I think divisible by 5 also, 10 also. Divisible by both. Divisible by 5 also, divisible by 10 also. Divisible by both. I think 10 will divide by 10. So let's see this one. I think minimal string is 10. 5 also, 10 also. Divisible by 5 and 10. If you take 5, 5 is not divisible by 10. So minimum is 10 length. Next one, I think 15 cannot be. 20. Next one 30. Next one 40. Next one 50. Next one 60. If you observe clearly, 10 difference. So with the 10 difference, there is a cycle. With the 10 difference, there is a cycle. Check. So AP series there. AP series is there. AP series is there. Some people are saying that, sir, I will do x into y. That is true. That is also correct. That is a DFA, not minimal DFA. Right? Whatever psi, whatever you are saying, correct. But that is a DFA. That is not minimal DFA. Minimal DFA is something like this. So blind answer is 50 states. That is perfect. You can do product machine. You can do product machine. You can get the 50 states. Product machine and you can get the 50 states. But this problem can be solved with 10 states only. Yeah, is it okay now? Now is it fine? Is it fine now? Can we go further? Can we go further? Yeah. So now see the next one. Now see the next one. Minimal states in the minimal DFA. So I think the number of states in the minimal DFA. I think these are the formulas. These are the formulas, but right, sometimes formulas, if you follow, you may play game. Be careful. Be careful. You may play some small game. You cannot be the victim of their game. Right? If you observe clearly, right? So greatest common factor, right? R operator. If you see greatest common factor. GCD, right? GCD, right? Something like that. Next one, minimum number of states, end operation, LCM, right? Something like that. Please, you can verify. Best thing is find out the series. You will get to know some difference is there. With the help of loop, you can manage. So if you follow standard procedure, normal way, any problem you can handle. If you follow formula, you may become little bit victim. Please be careful. Minimum number of states, string length divisible by 5 and 10 and 15. 5 and 10 and 15. So you can go for a series kind of thing and you can try this also. Remember, end operator. all three people should divide. All three people should divide, divisible by 5 also, 10 also, 15 also. Right? So please find out. You will find out. If you want, you can check. If you want, you can check. There is a series going on. Right? There is a series going on. I think a first number, if you observe, you have to check carefully. So I think if you use the formula LCM, if you use formula, 30 is coming. If you want, you can check yourself also. 30, right? There is a series going on or not, verify. There is a series is going on or not, verify. What is the first number? What is the first number divisible by all three people? I think 30. The first number which will divisible by all three people. If you take 15, 10 cannot divide. If you take 20, 15 cannot divide. If you take 25, 10 cannot divide. I think 30. First number is 30. First number is 30. If you want, you can verify. Next number, maybe 60. Next number maybe 90. Next number maybe 120. Please verify. So some series is going on like this. So with the 30, there is a one cycle. 30, there is a one cycle like this. Right? Like that. You can verify. You can verify. Next one. Minimum number of states. String length divisible by 2 or 4 or 5. So if you observe clearly this series, right? First 2 there, right? I think next 4 there, next 6 there, next 8 there, next 10 there. I think 2 difference. 2 difference. 2 length, one cycle is there. Check. 2 length, one cycle is there. Please. Yes. So using product machine, you can do intersection, you can do union also, right? So you can do that using product machine. Do individually first, then multiply. Right? You know the total procedure. I don't want to say the total procedure once again here. So 2 into 3, 6 states, right? So you know product machines and all. Next one, right? DFA for binary numbers divisible by a given integer, right? This one, please take care. This one, you please take care. DFA, where for all binary numbers you want to accept, all binary numbers are divisible by a particular number, So please be careful. Some formulas are there, please handle it. So I think let me read those formulas. Case 1, right? All binary number divisible by 8. 8 can be written as 2 cube. All binary numbers divisible by 8. 8 can be written as 2 cube. If you want, you can verify number of states in that particular automata. Minimal DFA, k plus 1, 3 plus 1, 4 states. Right? So whatever k there, k plus 1. Whatever 3 there, 3 plus 1. Right? Next one. Right? That is if n is powers of 2, that is the story. If n is not powers of 2, n is an odd number. If n is an odd number, all binary number divisible by n. N is odd. Answer is same. N states only. If n is odd, n states. All binary numbers divisible by n. N states. So if it is odd number, right? N states. Correct. Right? If it is a powers of 2 power k plus 1 states. Suppose assume that 12. Right? Be careful, everyone. Assume that 12 can be written as 2 into 6. right? So this can be written as 2 into 3. This can be written as 2 square into 3, right? So you are able to write, it is not a odd number. It is not a odd number. It is not exactly powers of 2 also. It is not exactly odd number. It is not exactly powers of 2. It is almost like mixing. It's almost like combination of powers of 2 and odd number. So odd number, right? 3 there, 3 states. Odd number, 3 there, 3 states. M there, M states. M there, M states. But 2 power k states. So k plus M states. So it is going to be now, right? 2 plus 3 states. 5 states. So can you remember this? Can you remember this? Can you remember this? So 40 can be written as 2 cube into 5. So it is a 3, it is a 5. 3 and 5. Right? 3 and 5. How much? 8. 8 is there. 3 and 5, 8 is there. I am not saying anything new here. I am not saying anything new here. Whatever you know, so I am reading once. So one table also there, see. One table also. If n is equal to powers of 2, answer is k plus 1. Answer is, so be careful, n is equal to 2 power k. K means log n. Right? So n is equal to 2 power k. Definitely this k is log n. So answer is log n, right? K is nothing but log n base 2, right? Plus 1. So be careful. K means log n base 2 plus 1 extra. Next one. N is odd number. N is odd number, simply n states. It is a combination of powers of 2 also and odd number also. Right? So for odd number, m is there. K plus k is there. K is nothing but almost like log n base 2, whatever it is. Whatever is there. Whatever that number that is. Right? Fine. Perfect. Next one, minimal DFA that accept all strings where the nth symbol from right hand side. Nth symbol from right hand side, 2 power n states. One excellent diagram will come, right? One excellent diagram will come. In the classroom, we done many things. From right hand side, nth symbol from right hand side is x, 2 power n states, right? Nth symbol from left hand side, that is a very small diagram, n plus 2 states. N plus 2 states. Nth symbol from left hand side, n plus 2 states, because for n length, n plus 1 states required, one more 1 for the dead state. Right? Nth symbol from left hand side is n plus 2 states. Nth symbol from right hand side is 2 power n states. Right? 2 power n states. See, this is from left hand side. Where third symbol is, right? Third symbol is x, means left hand side only. Right? I think 3 plus 2, 5 states. Next one. Complement. Remember, complement will be done only for DFAs. Complement will be done only for DFAs. Remember this. Complement is done only for DFAs. So how will you do complement? Right? Just interchange final to non-final, non-final to final. That's it. In the given DFA, make final as non-final, non-final as final. Then you will get the complementation. Other than this, nothing there. Right? So keep the same structure. Everything is same. Don't change anything. Swap final to non-final, non-final. Make all non-final as final. Make all final as non-final. Do that. Then you will get the complementation. Right? Next one. Minimal DFA for even length string. Right? Accept all strings of even length. So this is the even length. So you want odd length. So complement to do. Odd become even, even become odd. Right? So yeah, perfect. So can you see this one? Can you see this one? L union L complement, right? L, whatever L is there, L complement having other than that. So if you do union, it will become sigma star. Whatever L is there, L complement is other than that. If you do intersection, nothing is common, right? L complement is nothing but sigma star minus L, right? That is everyone know this. Converting N of A to DFA. Converting N of A to DFA, you know that procedure very well. But remember, that one really not required in the GATE exam. This only required. If N of A has n state, equivalent DFA can have up to 2 power n states. N of A having n state, equivalent DFA contain 2 power n states. Right? 2 power n state. This is the only thing which is required. Maximum 2 power n states. Maximum 2 power n states. Remaining, I think you know that procedure very well. I don't want to waste your time. Right? So conversion. Right? Conversion story you know very well. N of A contain n state, equivalent D of A contain 2 power n states. Next one, epsilon n of A to n of A. That conversion also, no one will ask you. No one will ask you. For your convenience, you can read one time. Right? Epsilon n of A to n of A, for your convenience, you can read one time. Most probably no one will ask. You can check one time. You can check one time. Next one, total number of DFAs possible. Total number of DFAs possible with n states. Total number of DFAs possible with n states and m length alphabet. M length alphabet. Assume one of the state is initial state. So initial state is one of the state, one possibility. Next one is going to be right. I think n states are there. Final states can be any subset. So 2 power n, because final states are subset of the set of states. So all possible subsets. You can take any subset as a final state. So 2 power n subsets are there. Next one, transition functions. If you see, right, on every symbol, if you observe clearly, on every symbol, n possibilities. Like that, m possibilities are there. M times n power n. Like that, n times you have to do n power m, n power m, n power m, n times. So n power m whole power n, which is going to be n power mn. So this is the final one. Number of DFAs possible with n states where alphabet size is m, one of the state is selected as the initial state. So that is the answer for this. Now I think same one problem I given, 3 states x, y, z, and alphabet is AB, where x is initial state. So if you observe clearly, number of states are 3. Okay. Alphabet is 2. Okay, that is also okay. Now if you observe clearly, starting state only 1. Okay. Final state he didn't mention. Final state, it may be final, may not be final. May be final, may not be final, two possibilities. On symbol A, it can go out of these 3 states anywhere. Three possibilities. It is going to be all 3 people. If you observe 3 power 6. If you observe here, it is a 2 cube. 2 cube into 3 power 6. So this is the answer. Same thing. We are not doing anything. Same thing. Next one, prefix. If string W is equal to this one, A1, A2, A3, and so on, then its prefixes are epsilon, A1, right? Next one is going to be, right, A1, A2, A1, A2, A3. So these are all prefixes, If string is ABC, prefixes are these, right? So if the n length string is there, n plus 1 prefixes. Empty string is also one of the prefixes. Everyone know this. Design DFA to prefixes of L. Let us assume L is equal to this. L is equal to ABB. Already DFA is there. Assume. DFA already there for this. DFA already there for this. Right? ABB go to final. Right? ABB go to final. So if at all first symbol is B, dead state. If the second symbol is A, dead state. If the third symbol is A, dead state. If the fourth symbol A or B, dead state. That's okay. Dead state behavior, that is okay. Everyone know. But I want, this is language L. Right? For the language L, I have already DFA. Prefix of L also I want DFA. Then what is the answer? Nothing. Starting state onwards. Right? The path where you are going to final state. Make everyone as a final. Then automatically you will, this is called prefix of L. So what I mean to say is, for the L DFA possible, prefix of L also DFA possible. The only thing is starting to final, whichever path you are going, in that path make everyone as a final. So like that. Suffix. Similar way suffix also. Then how similarly suffix? First of all, construct for L. This is for, let us assume that S1, S2, S3, S4, right? So ABB, all suffixes you want to create, right? This is the language L already automata available. Language L already DFA available. Now for all suffixes, for all suffixes you want the right DFA. So what you do is make every state as initial state. Make every state as initial state. Every state as initial state you do. So take one more new state S. Every state as initial state you do. Epsilon, 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 epsilon. Then over. Then it will accept to, if you observe clearly, then it will accept to, right? Only, right? Epsilon also, only B also, only BB also, only ABB also. What I mean to say is in the previous one, make every state as a final state. But here, make every state as initial state. How can you make many initial state? Take one common initial with the help of null production, you can make it, right? Perfect. Modify the original DFA to allow starting right from any state. Mark the original final state as the only final state. Same thing. Same thing you can do for substring also. Same thing you can do for substring also. Then how? I think mixing of the previous two you do. Mixing of the previous two things you do, you will get the substring also. So if any string, for any string you have a DFA, substring of that also you can construct a DFA. How? Make every state as a final state, make every state as initial state. If you do that, you can handle the all substrings, right? So how many substrings possible for A, B, C? These are the substrings possible. Formula is this. One time, please go through it. One time, please go through it. Right? So formula also substitution, please check. Next one. Regular language may be finite or infinite. Every finite language is regular. Every regular language is, for every regular language, finite automata is available. Decidable problems are finite automata, emptiness problem, finiteness problem, you know very well. Membership problem. Next one is equivalence problem. Next one is universal, right? Universal problem means accepting everything, right? So just to do complementation, empty or not verified. Next one, intersection, union, complement, right? You're getting intersection, union, complementation. You can do product machine. Right? That is the reason it is also a decidable problem, right? Intersection of two finite automata is also finite automata. Do you have any, is it decidable? Is it decision problem? Yes. Product automation possible. Union also possible. Complementation, interchange final to non-final, that is also possible. DFA equivalent testing, yeah. I think equivalence of two finite automatas, I think there is a table filling method is there, you can check it. So this, in the classroom, we are already discussed. Equality problem is a decidable problem. Equality problem is a decidable problem, right? Next one, finite automata with output, more machine, melee machine, right? Both more and melee, both are deterministic in the nature. They both are deterministic. Next one, this means that for every state, there is exactly one transition for each input symbol, just like DFA, true. Next one, if you go to the final state, in the more and melee machine, number of final states are 0 because they are not language recognizers. They are output generators. That is the reason. Next one, output length, if you see, for n length string, more machine will produce n plus 1 length output. Melee machine, for n length string, it will produce n length output. Output length is n only. So for a language, if minimal DFA exists, then it is unique. In the similar way, minimal more machine, minimal more and minimal melee machines are also unique. Remember, in the total automata, 3 people are unique. Minimal DFA unique, minimal more machine unique, minimal melee machine is unique. Please understand. In the total TOC, 3 people are unique. Remaining are not unique. Only these 3 people are unique. Minimal melee machine unique. Minimal more machine is unique. Minimal DFA is unique. Please be careful. Right? So more machine, about the more machine. In the more machine, state if you know. In the more machine, right? I think it is a more or melee. Let me check here. He is talking about more machine. Please see this. In the more machine, if you see the output, if you know state name, you know the output. State name, if you know output, because in the more machine, outputs are there in the state only. See, state Q0, output is 1. State Q1, output is 0. So in the more machine, output is based on the state only. In the Mealy machine, output is based on state also, current input symbol also. See, output function lambda, right? If you know state, if you know input symbol, then only output will come. This is the transition function. It's okay. This is the output function. In the Mealy machine, output is based on state also, input symbol also. In the Moore machine, output is based on only state. Only state, right? Be careful. Closure properties of regular languages, right? Closed under the following operation. Remember that table is important. All the table, please take care, right? These are all the things you know very well. It's a very, very important table. Very, which are not closed. Subset is not closed. Infinite union is not closed. Infinite intersection is not closed. Right? You can see the table, whatever you have. Right? Whatever table you are following, please follow it. Next one. Regular. Right? Union always regular. Regular, non-regular. Union may be regular, may not be regular. Non-regular, may be regular, may not be regular. Only this is guarantee. Remaining things, no guarantee. Next one. Check the following, right? How to check the given languages are regular or not. Finite language is always regular. So it is a finite language regular. Infinite language, come here. Infinite language, right? So alphabet size is 1. Infinite language, alphabet size is 1, like a power n, like that. Right? Alphabet size is 1, like unary languages like a only, right? So forms arithmetic progression like a power n, where n is greater than or equal to 1. Arithmetic progression, if you want, you can check, that is a regular. Arithmetic progression is the regular. See the example, a power n, where n modulo 3. So I think AP series going on. It's regular. Next one, does not form AP, is going to be non-regular. A power n, where n is prime, there is no AP format, prime series format there. So it is not regular. Next one, alphabet size is more than 1. Alphabet size is more than 1. I think 2 symbols, a power n, b power n, where n is greater than or equal to 1. Then comparison is there. So I think a's and b's comparison is there. Then non-regular. Comparison not there. That is going to be regular. So a power n, b power n, where n is less than, right, something. Because of it is a finite, it is a regular. Next one, a power p, where p is a prime. P is less than, I think it is a finite, so regular. Next one. L is equal to triple A plus double A whole star. Triple A plus double A whole star. I think directly regular expression possible, right? Directly regular expression. So it's a regular. That's okay. Otherwise, you can see the series. Can you see the series? Here? Interesting answer. Can you see the series here? 0 length possible because of whole star. 2 A's also there. Next one, 3 A's also there. Next, 4 possible, 5 possible, 6 possible, 7 possible, and so on. If you observe clearly, right? So forget about the first thing. Until here, forget. If you observe clear, everywhere 1 difference. Starting not matching anything, but afterwards, everywhere 1 difference. Means GP, right? AP series possible. Some point onwards, AP series possible. So it is regular. Sir, starting is not possible. Here 1 difference is there. Starting 1 difference not there. Starting difference is not there. Starting create. So let's see how the starting create. So 2 length, right? 2 length. Go 2 length first. Okay. You came here already 2 length. Next one, 3 length also, 4 length also, 5 length also, 6 length also. So I think you can handle it. 2 length also, 3 length also, 4 length also, all the things are happening. So something like this. So here, see, this is the one, I think loop. 1 difference. Right? This is the 1 loop, see, 1 length loop. Right? Starting people are not matching, right? Draw separately. Not matching people, draw separately. Matching people, right? Loop matching. So write the loop. Anyhow, finite automata possible. States you please take care. So regular. Next one, a power 3n plus 1000. Right? It is also AP series possible. Please check. Arithmetic progression possible. Mod 3, something like that. It's a regular. Next one, a power m whole power n. AP series not possible, so it's non-regular. Verify. A power p whole star, where p is a prime number. You verify properly, right? Here also AP series will come because a power p whole star. A power p whole star. That is the reason. Next one, a power n square, verify, right? GP series not possible. Sorry, AP series not possible. Next one, a power nn into a power m square, whole star there, Please verify, right? Again, if you verify properly, it became like this. I think 1 length, 2 length, 3 length, all are possible. Verify. That is the reason it is regular. AP series possible. I think it is a finite. AP series possible, regular. Right? If you see here, m plus n is equal to 10, finite. AP series possible. Sorry, finite means regular. Next one, m minus n 10. M minus n 10. You may be thinking it is a finite, but be careful. Their difference is finite, but they are not finite. And one more thing is, if you want, you can verify also. It's not forming the AP series. Please check. It's not regular. Next one, xy, where xy belongs to a plus b whole star, where x is equal to y. All even length string. If two people are equal size, means you kept side by side. It is 2. So even. It is 3. It is even. Right? It is 1. It is even. So even length string. This is the automata. AB. Automata it is. So it is also regular. Next one, a power m, b power n, where m plus n is even. Same story. It's regular. Next one, w power x. Where w comma x belongs to a plus b whole star. Verify. All the strings are coming. How? W make it as epsilon. Right? WWX. I think x here. Sorry for that. I changed, unfortunately. WWX. So if you make W as epsilon, all strings will come. It's regular. Right? WW. Right? So you cannot make, right, W as epsilon, because if you can make, but what about other things? Here other things are taken care by X. So that is the reason it is possible. Here not possible. Please check properly. So until here I done. In the next class, we'll see. Remaining. Okay. Thank you. In the next class we'll see remaining. Thank you so much, and good night. Thanks everyone. Thank you. Good night.